Uh, for making sure that the remaining hardware. But what is the remaining hardware distributor? We have the remaining hardware. 500.
Recording in progress.
Go ahead. Good morning, everybody. It's nice to see you all again. Today we have a very special guest with us. That's why before we begin with our actual lecture, we'll go around the table and reintroduce ourselves. Okay. So I will start with myself. My name is Ahmed Aziz. I'm an assistant professor. I've been here since August 2019, so 5 years in Tennessee. And my research interest includes nanoelectronics, chip design, and emerging devices. Let's go clockwise, maybe. Oh, sorry, I missed. You come first. Go ahead.
I'm good. I'm a graduate student, PhD student, at the University of Tennessee, computer science.
Hello everyone, I'm MD Rahatul Islam. I am in my 5th year of my PhD here. I'm doing my PhD under Dr. Rahatul Aziz. My research interest includes beyond CMOS technologies and emerging devices.
I'm Jacob Weller. I'm studying electrical at Mississippi State right now. So.
Hi, I'm Shamil Alam. I'm also a PhD student and I work with Dr. Aziz. And my research focuses on device modeling and circuit design.
Hi everyone, I am Rahatul Islam Udoy. I am a PhD student in the ECS department of the University of Tennessee, Knoxville. I work with Dr. Aziz and my research interest is in sensor computing and atomistic simulation. Thank you.
Hello everyone, I'm Arifa Shmi. I'm the high school teacher responsible for all the science students. I work at UT Knoxville since 2009. I work in STEM and art, and it's like a variety of subject areas. So every year it's a different challenge project. So I love my job. Thank you.
Hi, I'm Zainab.
I want you to talk loud so the guys over there in the other room hear you. Oh.
Hi, I'm Zainab. I'm Zainab and
I'm still here. Louder, louder, louder.
Hi, I'm Zainab and I'm a junior at Harnell Academy. Hi, I'm Yasmin Football and I'm a student at North Academy in the
I'm Tom Clark. I'm helping improve things for the project and outside evaluator from NSF.
I'm Arif Hadi. The last time I got into electronics was back in 1975. So I'm on the old generation, but I work on high frequency stuff, microwaves, antennas. I'm glad to organize this.
I'm Hassan Ahmed. I'm a junior at Noor Academy High School.
My name's Adam Abdullahi and I go to Noor Academy and I'm in 10th grade.
I'm Shihab Al-Akhfash and I'm also a sophomore at Noor Academy.
I'm Adam Murads and I'm a freshman at Noor Academy.
I'm Muhyiddin Hashani and I'm a freshman at Noor Academy.
I'm Dylan Haynes and I'm I guess senior at Mississippi.
Right, that's everyone. introducing yourself. We'll get started with the actual lecture today.
Jody is on her way. She's.
Oh, sure, no worries. She can join us and we will let her introduce herself when she comes. We'll get started with the actual lecture and Udoy will teach us something new today. And this is very exciting because we are moving towards our actual hardware project, okay? But before we do so, I want to show you a high-level overview of what we have covered so far and why have we covered specifically those things, okay? Because, 1 second. Yeah, it's working now. All right. So you might be wondering that, hey, these guys are teaching us so-and-so, KCL, KVL, MOSFET, these and that, but is there any end goal? Why are we learning specifically those concepts and not the others, right? So I just want to take 5 minutes to show you an overview of what we have learned so far. And the reason why we specifically chose those topics, we definitely didn't cover everything in electronics, right? That's impossible. So we started with a very basic discussion of electrical components, starting from resistors, what happens when you have multiple resistors in series, parallel, or more complex combination. What if you apply a voltage across a combination of resistors, and how will they each take shares of that voltage, right? So basic that I hope it was like a kind of like a way for you to get started. Even if you don't have any background on electronics or circuit design, I hope that you were able to just join in through that lecture, even though it was more like super repetitive for community college students, but thank you for your patience. So, and then we moved to the next lecture where we discussed some circuit theory, including KCL, KVL, and we also did some simulation to get you started with the concept of you don't necessarily need to go and make something in the lab to test something out. You could always use a simulator to test your theories, right? But we also did some hardware testing in parallel to simulation so that this thing really works in real life, so that you have more faith in the simulation tools. The next step, we started getting more serious. Things started getting a little bit more complicated. I understand a bit of a stretch, especially for high school students, but I hope that you were still with us. You didn't feel like you're lost, right? If that's the case, you need to come and talk to us. But we tried to keep it, general. We started discussing the beauty of semiconductors. Why semiconductor? Why not just metal and insulator, right? We all know metals are good conductors, insulators are bad conductors. Why you need something in between? So we discussed what happens to semiconductors when you dope, when you use impurities, and you could tune their properties, which is the most important thing about semiconductors, that you could actually tune their properties, not just take what is given, right? And then we also discussed some small scale circuits with diodes and other small semiconductor devices. Next, in the very last class, we basically dived into one of the most advanced devices with semiconductors that we use in chip design, which is MOSFET. There are other devices like BJT and whatnot, but MOSFET is one of the more advanced form of devices that we use in our electronic industry. And I think it was Shamil, was it, who taught you MOSFET? Mazhar, sorry, my bad. Mazhar taught you the basics of MOSFET. And it's a device with multiple terminals. It has some interesting properties. It allows you to tune its property with certain applied voltages. I hope you guys all remember that, right? Now, here's what we're building to. These are all devices. You have one single MOSFET, imagine that, right? When you use multiple MOSFET in a structured, planned way and connect them in a circuit, you get specific functionality out of those circuits, including, for example, these are some representative circuits. These are logic gates that allow you to do AND operation, NAND operation. We also discussed what these logic operations are, right? So apparently in this circuit, you have 4 MOSFETs, as you see. So if you understand the properties of MOSFET, it will be easier for you to at least understand on a higher level how and why these circuits work and why do we design them the way we do. Okay, that's the idea. Now, we are actually at the next step, we will start using these circuits, devices and circuits to make a hardware project. And Udoy will tell you more about the specific project. You'll be using some sensors, some chip, including microcontrollers. You'll be using a more advanced simulator to design that and test it in simulation first, and then actually go ahead and implement and see your project in fruition. Okay? Now, as you see, without having basic knowledge of MOSFET, you don't even know why you are designing the circuit this way, or why are you using this particular component, not the others. Okay? So that has been our goal all along. to at least help you develop a baseline so that we are all on the same page, and then we start using this for actual design. One other thing to mention, remember in the very first lecture when I showed you how many transistors are on a chip? Do any of you remember the numbers that I talked about? How many transistors are in a modern day Core i7 chip? Is it in thousands, millions? Millions and billions, right? Thank you. Yes, it's in billions. In this circuit, you're looking at 4 devices, just 4 transistors. So just imagine 4 to billions. It's a huge jump, is it not? Obviously, you're not going to design those circuits or those systems manually. Nobody can design billion devices manually in a system, right? We use automation tools, we use simulators to do so. But the underlying principles will not change. If you could design one small component really nicely and optimize it to the fullest extent, then you could use a software, an EDA tool or electronic design automation tool to basically repeat that process and design billions. That's the beauty of chip design. Okay, we are heading there. That's our end goal. But at the intermediate step, we will do a project, as you see here, with discrete component. So there are discrete electronic component that you could use, like one resistor, one transistor, one microcontroller, connect them together on a breadboard, and you see how they work, how they interact, and then you basically translate it over to millions and billions by going through the VLSI process. Okay, that's the end goal. So after going through this project, I hope you'll be more confident about using electronics and electronic component. And then the next step will be basically making a full-fledged chip that actually does something. Maybe an arithmetic logic unit that you could use in a calculator, for example, right? We'll tell you more about it. One of the reasons why I'm not giving you a full overview of the entire activity is because I don't want to scare you, because these terms will look very scary. Right? So I'm just gonna give you a high-level overview of where we are headed. But as we take this journey together, I hope things will make a lot of sense, and this will be more like puzzles that we are all solving together. Right? With that, I'll stop. By the way, Udoy will be using a microcontroller for this project. There is a chip inside the microcontroller, by the way. Okay? So you're basically also a user of the chip that you can eventually design by the end of this program. All right, with that, I'll stop. We'll get to the real part of the lecture. And I see that we have 2 more, participants joining us. Could you introduce yourself? You can reintroduce. I know you, but
Jody Lynn.
yeah. So we have a guest today, a special guest today. So for I'd say maybe some more about your background.
Tom is our external evaluator from NSF. And he heard and saw you many times on the Zoom links.
Okay.
So he knows you much more. So he came to visit to see people in person. And of course, that will help him and us to evaluate ourselves in the long term. For example, evaluation, but he really wants to touch base with everyone.
Nice to meet you. I'm Jody Lynn. I'm a student at Pellissippi State Community College. My major is cyber defense, and I'm about halfway through the program. So, liking everything I'm learning, and also everything as well in this internship as well as going along and kind of feeding that and fostering that. So all good things.
Thank you.
And I'm Nolan Robinson. I'm an undergraduate at UT right now. And I'm a senior, and I'm here to help you guys. So if you guys have questions, ask me. Make sure you guys use me.
Thank you. So before I let Udoy start, one request for everybody. When we have questions, and I hope we have many questions, please ask that question and also mention your name. This is, this will help us, transcribe the audio in a way that people could relate. Okay. So before you ask a question, just say, "Hey, I'm so and so, and this is my question." Thank you. Udoy.
Okay, hello everyone. I have already introduced myself actually, so let me do. I am Rahatul Islam Udoy. I am a PhD student in the ECS department. you already have know me because I have already taken classes of you previously. So let's get started. As I have promised in the previous lecture that in this class I will be talking about the hardware project that we are going to accomplish. The project description is written in this slide. I'm not going to read this slide, but rather I have prepared an animation for you to easily understand the project. So this is written down for documentation and for your reference. So let's understand the project in the animation. So as you can see that there will be several parking lots. Okay. So in this example, there are 4 parking lots, and there will be sensors embedded in the parking lots. So and sensors will be connected to a microcontroller. We will be using Arduino as a microcontroller. And as Dr. Aziz mentioned that there is a chip inside the microcontroller. I will talk about this later. And there will be a display where we will show how many parking spots are available. Okay, so it's yeah. So at first, let's see that there are 4 parking lots. Now there are no car on the parking lot, and 4 cars are waiting to enter into the parking lot. So the project will be like this. Suppose 1 car enters into the parking lot, then the display will update the available parking spot number, which is now currently 3. In a similar way, if the second car enters, the available parking spots will be updated to 2, and so on actually. Okay, so yeah, this will be the project. Very simple description of the project, as you can see. And as Dr. Aziz mentioned, there is a chip inside the microcontroller. Here we are using the chip. I mean, this project is actually about the application of a chip to further motivate you to design the chip yourself. Okay, so this is actually an application of a chip. You can say this way. So let's start one by one, maybe. So we, as a microcontroller, we will be using Arduino Uno. In the previous class, I mentioned, I know I mentioned that we will be using Arduino Mega, but for this project, I think Arduino Uno will be sufficient actually. So in what is a microcontroller, or what is Arduino Uno? As you can see that this is a popular open source microcontroller. What do you mean by open source? By open source, it means people can write codes, and people can make libraries, and they can upload it in the website, and anyone can use it. That's why it's open source actually. You do not have to pay anything to use the libraries, okay, to use the Arduino. So yeah, and it actually acts as the brain of a different project. And what are the main components of Arduino? As you can see, the main component is the chip here. As you can see, this is lying behind. This is sitting on the board, and there are some input pins. There are some output pins. So it can take output.
I have a question.
Yeah.
This is Ali. Can we expand this? Because in our parking lot, I was asked before to develop something like that. For the first floor, second floor, we have 7 floor. Can we do that through this project and they design?
Yeah, sure.
System, which not expensive.
Yeah, sure. Of course, it can be done because it's very simple project. I think because it only needs some sensors which are very reliable, and it can also for I think for a large number of parking spots, you will need a large microcontroller or several microcontrollers. So yeah, it's doable. It's easily doable.
Mention how much each when you're talking, so we know how much is going to cost. I would love to say this group was able to design a parking system, and all the students and faculty will appreciate you and be thanking to you guys if you end up with something like that. You can get some money also after it.
So currently, this Arduino Uno can handle 6 pins. So this can handle 6 parking spots, one Arduino Uno. But if we can manage Arduino Mega, which can take 16 inputs, and that can handle 16 parking spots. So Yeah, so for 16 parking spots, the cost will be somewhere like $35. Yes, so in for this project, the analog in there are some input pins. As you can see, these are input pins like here A0, A1, A2, A3, A4, A5. So there are 6 analog input pins. We will be using 4 input pins to sense the sensor, and the rest of the 2 we will keep the rest 2 pins for the LCD display. I will explain it later one by one actually. So let's move actually. So for the sensor, we will be using photodiode. The photodiode model will be BPW34, and it's a 2-terminal device. As you can see, there is one anode and the other one is cathode. It's very simple. I have actually mentioned you the working principle of photodiode, how it works in the previous class. So I'm not going into that. In a summary, if light falls on the photodiode, then there will be some voltage generated across the terminals, and based on those voltage measurement, we can take decisions actually. Okay, so we will be using an LCD to show the available parking spots or some messages. I mean, so this is a 16x2 LCD. I mean, what does it mean by 16x2? 16 is actually the column number. There, in the hands-on project, we will show you that there are 2 lines that can be displayed in the LCD. In the first line, in both lines actually, each you can display 16 characters. So 16 characters in each line, and there are 2 lines. That's why it is called 16x2 LCD. Okay, so we will be using that a lot in the next step. So there are 4 pins to connect in this LCD. The first one is as you can see in the left side of the in the LCD, there are 4 pins. In the first pin, it is ground. You need to connect the ground of the circuit with this pin, and VCC you have to give the power supply to the LCD through this VCC pin, and you can provide the power supply through the Arduino or microcontroller itself. HPA, HCL, these are the serial data, serial clock line and serial data line, and this should be connected to the microcontroller. I will show you. This is just component introduction. When we will connect, we will understand very easily. So there will be 2 phases of this project. In the first phase, we will be doing simulation to test our idea actually. Before going into hardware, we'll test this project using simulation, and I have introduced you with a software, an open source software as well, which is Tinkercad. Right? I have shown you how to use Tinkercad. So using that Tinkercad, we can actually simulate the project first to check if the project works. Okay. So without talking too much about the theoretical thing, let's actually dive into the project. Okay, so let me open up the Tinkercad. So it will be great if you, as I previously showed you how to open Tinkercad, you already know. Suppose, sorry, yeah, I assume that you have your laptop with you, so please open Tinkercad and just open a new circuit. So I'll give you some time to open the Tinkercad. As you know that we need to just go to a browser and search for Tinkercad, and if you have an account, you will already yeah, you will see the dashboard. So if anyone faces any problem to open Tinkercad, just let me know.
So did we order those parts?
Yeah, I think we have breadboards and other stuffs, and we need microcontroller and the LCD actually.
We need to buy those. So
Yeah, I have sent the list to Dr. Aziz. Yeah, he will be ordering, I think.
okay, so you can send it to me. We can
yeah.
hear it. UN partners. And you are assuming each student will have his own kit, right?
Yeah, I think so. We have first set of hardware already, but we have breadboard and other jumpers, etc. already. So yeah, so in the next phase we need to buy just the microcontroller and the LCD. Okay, so have everyone been able to open the Tinkercad? So if anyone face any problem, let me know. Just let me know. I will just show you how to open. I think.
Yeah, I can't see the URL.
Okay, so yeah, actually we have worked with the Tinkercad. That's why I'm not showing you that. Showing the. So you have to search for Tinkercad. Tinkercad.com.
These are in the URL. It's in the URL. Like it is too small. Like text.
Now let me write it.
You can write on the search.
Yeah.
In the middle search. Yes. That's larger. Just
So we able to open it up.
yeah.
Okay. No, just on your own. So are we on the same page? Yeah. Is everybody has? Can you get the page? Yeah. So let's start. As you know that I have already shown you that you can just press on create and go to circuits. Okay, create then circuits. So the design environment will be opened. Have you been able to open the design environment? Okay, so if anyone face any problem, just let me know. Okay, so as I have mentioned that previously that in the components section you have to select all. Okay, in the top right corner there is a component section. You have to select all, and then let's search for Arduino first. Okay, Arduino Uno. Okay, so if we start writing the spelling, I mean ARDU, the suggestion will automatically show you Arduino Uno R3. Okay, just select that, and there will be some components here. So you have to just select from a microcontroller section Arduino Uno. Just click on that, and this will be appeared in your screen, and just click. Then just place it on the screen by just a left click, and the visualization of Arduino will be shown in the screen. Okay, so this is the Arduino, and as you can see, this is the chip I was talking about. The chip name is called something 80 mega 3280 something. We do not have to worry about the chip name. Just this is a chip. This is a microcontroller chip, and this is embedded on the breadboard. So these are the pins. Okay, these are the pins. This is ground pin. This is ground pin. This is 5-volt pin. And this is 4 volt pin. So we will not be needing all these pins. The important pins are these analog pins, because we'll be reading the sensor data via these analog pins. So as I have mentioned that there are 6 input pins, right? The pins are named like this: A0. This pin is called A0. This one is A1, A2, A3, A4, and A5. Okay, so we have to connect the sensors to these pins actually. So the microcontroller takes sensor input, right? And there are some this portion is called USB adapter. I think you can insert the USB pin, and how this Arduino will work. You have to upload code. Okay, you have to upload a programming code inside this microcontroller. How will you upload it? Okay, yeah, you can upload this via a USB cable. With the Arduino, the USB cable is already given actually. So in practical life, I mean in real life, the Arduino, you will do Arduino coding in a software. I mean in a software called Arduino IDE. You will need to install the software inside your computer. When we will start the main hardware project, I mean the hardware component. So in this class, we do not need to install Arduino IDE. This Tinkercad will be sufficient because this Tinkercad has already an coding environment. So we can code inside the Tinkercad and upload it to the Arduino board. Okay. So let's how to code this. I mean how to write code for this Arduino. So for writing code Arduino, you have to go to the top right corner. Here it is written code. Okay, so go to this code, just click on it, and there will be some options here. So please go to the code, and then there will be a drop down menu here. As you can see, by default it is set to blocks. You have to click on it and set it to text. Okay, so if there is any any pop-up, just press click continue. So yeah, so I'm telling you again, this is go to code and then select text from this drop down menu. Okay, then there will be a coding environment here. So here you can code, and this code can be uploaded to the Arduino board. Okay, so here this is a default code. As you can see, a default code is already written here. So the Arduino code has 2 parts. Let me just zoom it further. So Arduino code has basically 2 main parts. The first part is void setup. Yes, setup is a function, okay, and loop is another function. So void setup is a function, void loop is a function. As the name suggests, as you can see, void loop. What does loop mean? Loop mean it will go again and again. Okay, so I mean this will be executed again and again. I mean forever. Okay, so this is loop. I mean this will be continuously executed. And the void setup section, this section is executed only once, and then it goes to loop and loop functions, and then it will continue, right? So let's understand one by one. Here it is void setup. This is where you have to mention the pin names. As you can see, so before going into code, just attach something with the Arduino. So as I have mentioned you that we will be dealing with photodiode sensor. Okay, so let's connect a photodiode first. Then we'll go to the code. So to get the photodiode, you have to just search here photodiode in the search box here. This is basically the component search box, right? So here you have to search for the component. So I am searching for photodiode. Here there is a photodiode option, so you have to select it and place it somewhere. I mean, yeah. So this is the photodiode. So let me just put this photodiode on a breadboard. Yeah, that way it will be mimicking the real life. So let's also search for breadboard. So this is the breadboard. You have to click it and place it somewhere. Okay. So and this is the photodiode, and we need to put the photodiode on the breadboard. So I'm putting it right here. So this is the photodiode. Okay. And now let me connect this photodiode with with an analog pin. So as you can see, photodiode has two pins. The first, the negative pin and the positive pin. The negative pin is called the cathode, and the positive pin is called the anode. Okay, so we have to connect this sensor to the microcontroller. Okay, so how should I connect? The positive terminal of the sensor or photodiode should be connected to connect an element. You know that. I think you know. In the previous class, I have already shown you that how to connect an element, right? So you have to just if you hover the mouse on the breadboard, the available pins in the column, I mean in the line, will be shown. You have to connect. You have to click any of the pins like this. Click on a pin, and there will be wiring come out. Okay, so this wire should be connected to what? An analog sensor. I mean analog input pin. I'm connecting this to A0. This is one of the analog input pin of the microcontroller. What will it do? The microcontroller will take signal from this pin of the photodiode. Okay, so the sensor is connected to A0 pin. Okay, and what will be the case for the negative? I mean the cathode. The cathode should be the negative pin should be connected to the ground pin. Okay, so I am connecting the negative or cathode side to the ground of the Arduino. Okay. So currently the photodiode is connected to the the Arduino. Okay. So have everyone been go to at this point? Yeah. Does anyone have any issues to connect that?
Where did you get from to get the pen?
So you have to take the photodiode. So search photodiode. Yes, in the search box, search for photodiode. Yeah. Okay. And put it on the and now you have to connect the positive terminal to the A0 pin of the microcontroller. No, below. Yeah, so cathode should be connected to the ground. Any ground pin. When it is ready, yeah, now it's connected here. Then you have to connect A0 to the positive terminal. Below there, yes, right.
Thank you.
So let's write the code now. Okay. So we connected a sensor to the microcontroller. Let's see how this how the microcontroller reads the sensor data. Okay. So let's go to the code section. And it's a default code. We do not need to use this necessarily. We do not need to use this line. We'll be coming to the void setup loop later. Let's write the void loop. So we have to. So this is actually the skeleton of an Arduino code. You will have a void setup function, and you have to write this way, and there will be a void loop function. You have to write your own code inside the void setup and void loop function. Void loop, as I have mentioned, that void loop will be executed forever. I mean, it will be continuously looping through these codes actually. So let's write the void loop first. So for reading the sensor data, there is a function called analog read. We'll be using this function. So okay, let's write one by one fractionally. So we have connected the sensor to what pin? A0 pin, right? Here I am writing a function analog read. This function will read the voltage of A0 pin. So A0 pin is connected to the sensor. So we have written A0. Okay. And the value, where should I? Yes, this will read the value, but we have to save the values in a variable. Okay, is somewhere. So this function will just read. Okay, it will not store anything. So to store this analog read data, we have to save this analog read data to a variable. Let's assume a variable called sensor 1. And this is a integer type. Okay, so this is the way we should write that. Here by int I mean that the value we get from the analog read pin, I mean the A0 pin, this will be integer type values. Okay, we do not need in this case because the analog read will generate some integer values. That's why we have written int here. So we have to write the type of the variable we are declaring here. So I am writing int because we will be getting from the analog read function. This will be integers, and this is a variable. I am saving the value of analog read A0 pin value to a variable called sensor 1. You can write anything here. You can write your name here as well. So this is a variable. So that we can call it later. So this is the type of the variable, and this is the variable name, and this is the function where the Arduino reads the sensor pin value. So what we are doing here, we are reading the A0 pin voltage and A0 pin voltage, and then saving it to a variable called sensor 1. Okay, so right now the sensor 1 will be saving the values of A0 pins. Okay, so now let's we want to read, we want to see the data. Okay, this analog read function will just save the data to in sensor 1, but we want to see it, okay, in the monitor or in a display. So to see the data, to see something on the screen, we have a function called serial print ln. Okay, so here what the second line will do, this will just not A0 actually. So this will actually print the data in a display. Actually, in a display means here we have a serial monitor. In the computer we have a serial monitor, and in the serial monitor we will be reading the data. We'll be observing the data. So how should I write this command? We have to write serial.println. Then we have to write the variable name. What should we see in the monitor? We want to see the sensor 1 value. Okay, so here the analog read is reading the A0 pin and saving it to sensor 1, and now we want to see what is the value of sensor 1. So I am writing the variable name here, which is sensor 1. Okay, so there is a serial monitor, and in that serial monitor, this line will show you the value of sensor 1. Okay, so then we need to write these 2 lines will be sufficient to read the sensor data. And let's move to the void setup section now. So in the void setup section, as I have mentioned that we want to see the data in a display. In a monitor. There is a serial monitor here. So to initiate the serial monitor, we have to write a line in the void setup section, which is like this: serial.begin. So in the void setup, why did I write this serial.begin? Because to initiate the monitor, there is a serial monitor to read something from the Arduino. There is a serial monitor to initiate, but to start the serial monitor, we have to write this line in the void setup section. Now, you can ask that what is 9600? This is called a baud rate. Okay, I mean the Arduino will be communicating with the serial monitor at a rate of 9600 bit per second. Okay, so why this 9600 specific 9600? Why not 5000? Why not 1 million? Because you have to maintain reliability and speed. Okay, so when the microcontroller communicates with the serial monitor, then that communication should be speedy enough and reliable enough. So this is something optimum rate where microcontroller can communicate with the serial monitor reliably and better. So that's why this is 9600. Everybody in the world actually use this rate because that is most reliable and most speed. Okay, so let's start. I mean, the code is I think it's good enough to read the sensor data from A0 pin. Just let's start. So I have you know already that how to start the simulation, right? There will be a start simulation button. You have to just click it, and the simulation will turn on. And I have mentioned you about the serial monitor. Okay, so in this Tinkercad, the serial monitor will be right here. Serial monitor. You have to click on it to open the serial monitor. So let me click on it, and this serial monitor is working because of the void setup code. We must initiate that serial monitor by using that code in void setup, which is serial.begin 9600. And let's see what is being shown in the serial monitor. Okay, it's now showing 0. Okay, continuous zeros. As I have mentioned, this is a loop. Okay, so it will continuously read this A0 pin data, and it will print the sensor 1 variable. Okay, currently it is 0. It is continuously printing 0 actually. And why it is 0? So here is our photodiode, right? So after running the simulation, if you click on the photodiode, there will be a slider. Okay, using that slider, you can just increase or decrease the amount of light on the photodiode. Okay, so currently it is on the most left side. I mean, there is no light. As I have mentioned in the previous class that if light falls on the photodiode, there will be a voltage generated, right? So let's start increasing this light level. See, if I increase the light level, as you can see, look at the serial monitor. It's now 82. Now you may wonder that it's not. What is the value 82? It's not the voltage. It's not 82 volt or something. Because microcontroller or Arduino actually converts the voltage level to some values. Okay, so that because the voltage level is very low, like 0.2, 0.3 volts. So to deal with that, it's very messy actually. So that's why it actually converts the voltage to some value, and you can just use this value to put something else actually to do something else. So here when the slide is in the middle, it's 82. It's showing 82. If I just increase the amount of light, it's hitting 85. So in our case, 85 is the highest value. Okay, and the lowest value is 0. So based on this value, we can take some decisions. Okay, so for 0, I mean for 0 lights, the value is 0, and for the highest amount of light, it's 85. Okay. So we in this place we can just actually take the data of the sensor which is connected to the A0 pin. In a similar way, we have to in our project we will be using 4 photodiode sensor to represent 4 parking lots. So let's edit the circuit. I mean, let's add some more sensors. So let's so before editing the circuit, I have told you before that you have to stop the simulation first, then you can edit the circuit. Okay, so let's stop the simulation by clicking on this button. So this simulation has been stopped. Now we want to add more sensors. I mean, 3 more sensors here.
There is a
So, at any point, if you have any question, just stop me and ask the question.
Slider that you had up for this.
Okay, so yeah,
Alright,
when you
it's all
hit,
on the same page.
when you start simulation, the top right corner, yeah, simulation, then you have to click on the photodiode. Then you got this, and then to read the go to full screen. Okay, so let's remove this portion by clicking. We need to see the serial monitor. Okay, so let's go to code. Here the serial monitor, where it is showing the value of the sensor. Okay, so if you slide that little bit, yeah, the value is changing.
So where does it need to be? 82.
We'll decide on that. Right now, we are just reading the data and just observing what kind of values it gives to us. So, yeah, based on these values, we will take decisions later.
Thank you.
So
There's just 2 separate rounds because.
By the way, just to add some clarity, can anybody tell me why are we dealing with this light level in the sensor? And how is that related to the project that you might be doing? Can anybody tell me? Yeah, there will be photodiode for sure, but what will change the light level? Yeah, go ahead. Thank you. Yes, exactly. So imagine if a car comes on top of the photodiode, that will, basically stop the light. So the photodiode will give you a value closer to 0. Maybe not exactly 0, but maybe 10, 15, right? And if there is no car, then you get a higher value. So based on whether or not the light level is beyond a certain threshold, you could decide whether or not there is a car. So that's where we are headed, okay? So all of this should make sense.
okay, so yeah, let me just describe a little bit about that. Okay, so currently our sensor is giving values from 0 to 82, right? When no light, when there is no light, the sensor is giving me 0 value. And when, in your case, it will be different. The values are not constant based on different photodiodes. The values will, the higher value will be different. So in my example, as I have shown you, in my example, the highest value is 82. Okay, so when there is a light, I mean full light, then the value is 82. So suppose this is a parking lot. Okay, so we have a photodiode right there on the parking lot. So when there is no car, the light will be highest or the lowest?
Highest.
Right? Highest, right? Because there is no car, light can easily fall on the photodiode and the light value, I mean, the level of light will be the highest. When there is a car parked over it, over this, suppose there is a car over it. Okay, so the what would be the light level?
0.
0. I mean the lowest or the 0 level. Okay, so how should we decide that if there is a car on the parking lot or not? Do you have any idea? Yeah, so from these values we can decide, right? How much value this is getting. So we can set a threshold. Okay, so because the chips will work on threshold, so we have to set a threshold. If the light level is below the threshold, then there is a car. Okay, and if the light level is above the threshold, then there is no car. Okay, so let's assume the threshold is 41. Okay, the midpoint of 0 to 82. So if the value is less than, we can set a code like this. If the value is less than 41, then we can assume that there is no light, that means there is a car on it. Okay. So if the value is greater than 41, we can assume that the light level is high. Okay. So the light level is high and there is no car on it, and we can say that this is the parking lot is free now and anyone can park on it. Okay, so that's what we will do. Okay, so let's.
Can anybody tell us why are we setting a threshold instead of just looking for, is it 82 or 0? Why aren't we doing just two extremes? Why are we looking at the midpoint? Is it below the midpoint or above the midpoint?
There'll always be some small amount of light.
That's good. Yes, there will always be some small amount of light. You're never gonna get exactly 0 unless you're literally putting your hands on top of it, and, you know. But there is other consideration as well. Imagine if it could be a sunny day, it could be a rainy day, right? Depending on that, 82 might be 75, 65, depending on the intensity of the light that you get. Maybe there is an angle. Is it 2 p.m. or it's 12 or is it 9 a.m.? Depending on that, there will be a different intensity of the light. So you can never rely on the two extremes. You have to set a threshold and see whether you have exceeded the threshold.
Yeah, thank you, Francis. So, yeah, so we are setting a threshold, and below the threshold, we are taking one decision, and above the threshold, we are taking another decision. So here we, let me go back to the Tinkercad. Okay, so here in this case, we have one sensor, and we can add other sensors. I mean, for this project, we will have 4 parking lots. Why? Because there are 6 analog pins, and 2 of them will be used for LCD display. I mean, liquid crystal display. So that's the remaining 4 pins can be used to sense the parking lot availability. So let's add other, in a similar fashion, just add other sensors, I mean photodiodes. Let me just copy this again, or I can just search it from here. So I'm taking 3 more photodiodes here and connect them with the rest of the analog pins. So in a similar fashion, the positive node, I mean the positive terminal of the photodiode will be connected to, okay. So I am connecting the second photodiode to A0 pin, okay. And the third photodiode positive terminal to A2 pin, and the fourth one to the A3 pin. And we have the negative terminals as well. So we have to connect the negative terminals of the photodiode or the sensor to the ground pin. Okay, so let me connect this to the ground pin.
We're going to be doing this with actual hardware in the next class. Okay, so no need to feel bad. This is just a way for you to just, familiarize yourself and be more comfortable. Sorry, Uday.
So as you can see that there are 2 ground pins, but we there are 4 sensors, right? We can have more sensors, and all the negative pins of this sensor should be connected to the ground pin, right? But there are only 2 ground pins here. Okay, so in this software you can connect as many, any number of pins to ground pin, but in real life you cannot connect more than one wire or jumper in one ground pin. So what will I do to mimic the real life scenario? I will do one thing. I will create a node of ground, okay, where we will connect all the grounds. So let me do this thing. So I am taking one ground pin, and I will be connecting this to this line. And as I have already mentioned in the previous classes, that how these breadboards are connected. These 2 lines, as you can see, the above 2 lines are connected horizontally, right? These all pins are connected inside the breadboard. So in Tinkercad, if you hover the mouse on the pins, this will show which pins are connected. Okay, but in real life, you'll not see this, right? So software is giving you some advantages, but in real life, as you know that I have already told you that this line and the below two lines, like these two lines, are connected horizontally. So if I connect one pin here, and these all pins will be connected. Okay, so I am creating a ground node here. So I am connecting the ground pin of the microcontroller to a line of pins in the breadboard. And now, if I connect any pins from this line, this will be connected to ground, right? You know that. So so now this line is your ground. The topmost line is now your ground. So if you need ground in any part of your circuit, you can just connect it from here. Okay. So this sensor, I'm just removing all the grounds from here. So all sensors are the positive terminals of all these sensors are connected to some analog pins of the Arduino, and the negative terminals should be connected to the ground. Okay. So I'm connecting this negative terminal to the ground here. So this whole line is now ground, okay, because these are all connected. So I am connecting this negative terminal to this ground line, and I will be doing the same thing for all these other sensors. The negative terminal of this sensor should be connected to this ground line, and the third sensor's negative line should be connected to this ground line, and the fourth fourth sensor's negative terminal should be connected to this ground as well. Okay, so these sensors are connected. So we have connected 4 sensors, right? Okay. So now we need to edit the code as well for reading these all 4 sensors. So right now we edit. Let me just make it bigger to easily see the code. Okay, so here let me rename it to sensor 0 because that way it will be easier. I have changed the variable name. Now in this line of code we are reading the analog data of A0 pin. Now we have connected in A1, A2, A3 and A4, right? So we have to declare we have to just copy and paste this line and change a little bit. So the first pin was A0 and the second pin was A1. So in this second line, A1 pin will be read. So I am storing the A1 pin value to another variable which is sensor 1. So sensor 0 pin will be storing the data of A0 pin, and sensor 1 will be storing the data of A1 pin. Similar way, I will do this for other 2 sensors as well. So I'm just writing the same thing again and again. So I have connected A0, A1, A2, and lastly A3. So these 4 lines will collect the data of pins A0, A1, A2, and A3. Let me just show you again. Here, as you can see, we have connected the 4 sensors to A0, A1, A2, and A3. That's why I have written here A0, A1, A2, and A3. So all these 4 pins will and store it in sensor 0. Sensor 0, sensor 1, sensor 2, sensor 3. Okay, so we have to actually see the data of all the sensors. To do that, we have to just, for the first case, we have written this code serial.println sensor 0. I mean, in this line of code, it will show the sensor 0 value in the serial monitor. In a similar way, we want to show the other values. I mean, the sensor 1 value, we want to show all the sensor value. I mean, sensor 1, sensor 2, sensor 3. So let's just copy and paste here and just change the variable name. Okay, so I'm just copying and pasting. So in the second line, it would be sensor 1, right? The next one would be sensor 2, and the last one would be sensor 3. So here in these lines of code, it will print the value of sensor 0, sensor 1, sensor 2, sensor 3, etc. In the serial monitor. Yes. Before running the code, before running the simulation, let me tell you that there will be a problem. Okay, there will be a problem. Let's see what will be the problem. Okay, so let's face the problem first, then solve it, right? Okay, so I have just run the code and let's see the serial monitor. So what is happening? It is giving me zeros. Okay, it will give, but but do you know which zero is for which sensor? Is it readable from here? Is it observable from here? No, because it's just serially printing sensor 1, sensor 0, sorry, sensor 0, sensor 1, sensor 2, sensor 3. We do not know which one is for which value is for which sensor, right? So we need to write something so that we can understand the serial monitor reading. Okay, so what will we do? We'll do something like this. We will print something else before. Okay, have you understood the problem here?
Yeah.
Firstly, yeah. So the problem. So let me describe a little bit and also describe the solution as well. So here now the problem is. Here the problem is in the serial monitor, it is printing the sensor. At first, it is printing the sensor value 1. I mean sensor value 1. Then it is printing the sensor value 2. I mean, I am naming it sensor 1. I have started from sensor 1. It is printing the value of sensor 1, then it is printing the value of sensor 2. Sensor 3. And it again comes back as it is a loop, right? So it will go back to sensor 0. Then again it will print sensor value 0. It will repeat the operation. Okay, so it is just like printing in serially. Just as you can see that here, it is printing the value serially, and we do not know which value is for what. So we can add something. What should we add? If we can add something like this, we can write sensor 0 value like this. Before this 0 value, before printing the variable. Let me just do that. Okay. So before the printing the sensor value, let me write a text that will by which we will understand that here it is the sensor value 0. Okay. So let me write that. So I have added a line here, serial.println sensor value something. So I have used double inverted comma. So what will this code do? You can write anything inside this double inverted comma and it will print on the serial monitor. Okay, so you can write my name is something inside the sensor, inside this double inverted comma. I mean, you can write anything that will be printed in the serial monitor. Okay, so I am writing sensor value 0, sensor 0 value, and it will be printed in the serial monitor. So that's how you can just differentiate between the values because between.
Can you make that text size a little bit bigger? Like, there's a way to do that at the top. Yeah, is it better now? Can you please see? Instead of zooming in, you could also. Right. It's much better.
Is it visible? Okay, so let's test it for now. Okay, so before the printing the sensor value, I am just explicitly mentioning that this is sensor value something, this is sensor value something. So before that, actually, let me print something else because that is too technical. Let me something. Let me write something. My name is something. Let's see. Is it printing properly or not? Let's check. Yeah, this is first. As you can see that this is serially, and we need to show the code as well. Okay, so what is it doing? Relate with the code here. So at first it is printing my name is something, okay, and then it is printing the sensor 0. Then it is printing sensor 1 value. Then it is printing sensor 3 value, and then again I have told you that it will run forever, and it will go back. Okay, then again it will print my name is something. Then the sensor value 0, sensor value 1, sensor value 2, and sensor value 3. So to distinguish between the values, we can write explicitly write this is the sensor value 0, this is the sensor value 1. We can write this explicitly to just better understand from the serial monitor. Okay, so let's write this. So I'm instead of my name is something, I'm writing the sensor 0 value. Okay, and I will just copy and paste it for all other sensor values. So for the next one, it is sensor 1 value. I'm just copying and pasting in front of all the sensor value lines. Okay, and there was other problems. The code was running too fast. We can delay it. We can add add an intention so that it was going too fast, right? It was very hard to see the values. So we can intentionally add a delay so that that do not run so fast. Take that. Okay, so yeah, what is this? I'm adding a line, so it's called delay. 300 means it's in the millisecond unit. So it's 300 means 300. It will delay for 300 milliseconds. Why I have added it? Because that way it is something. It's better now to read the values. So now currently, as you can see, that sensor 1, sensor all values are 0, right? Let me add some more delay. Two seconds, okay. Okay. So currently, all the, as you can see, that all the photodiodes is in the dark mode. That's why all the sensors are throwing me 0 values. So if we suppose I want to, what does dark mean? There is already a car over the photodiode, right? So dark means right now they are in the dark mode. So dark means there is a car above the photodiode, and let's just increase the amount of light. Suppose let's increase the amount of light in the second photodiode. As you can see, the sensor I have just named it. This is sensor 0. This is sensor 1, sensor 2, sensor 3. So this is sensor 1. Okay. So as you can see, sensor 1 value is right now 85, and all the other values are 0, 0, 0. So this is what we want to do. So we have set up our sensor measurement. Okay. Now let's move to the decision section. Okay. The processing section. What should we do with these values? We are getting some values from the sensor, right? So what will we do with this? So here we will be taking some decisions. We'll do some processing here. As Dr. Aziz mentioned that we have to set a threshold. Okay. So let's test all the sensors. So what is the highest value? It is ideal. So I think all the sensor values should be the same in the highest light case. So as you can see that if I set the light at maximum, the value is 85 for all sensors. So we can set at 42, right? So we can set the threshold at 42. So so we are getting values 0 from 0 to 85, and we are setting a threshold 42. So if the sensor value, so we'll take decisions like this. If the sensor value is less than 42, I mean the light level is less than 42, I mean the lower side, okay. So light level is low, it means that the parking spot is not available, right? So if the parking spot is not available, we will set this as 0, okay. And if the sensor value is greater than 42, we will set this as 1. We will just represent it as 1, because if sensor value is greater than 42, it means that there will the light amount is higher, that means there is no car on it, okay. So we have to take decision based on this value. So to take decisions based on value, on some value, we need to implement if else condition. So let me introduce the if else condition here. So how does it work? So you have to ask a question. So in a real life example, if you ask question, if it is raining, if yes, you have to do something. If not, you have to do another thing, right? So in coding, this work exactly in the same way. So let me write a code for that. For our case, what would be the case? So this is actually we want to implement. Okay. So let's jump into the code, maybe that way it will be easier. So here we will be introducing an if else condition here. So if in the coding language you have, in this coding language, this Arduino IDE actually use C++ coding language. So you have to write the code according to the syntax of C++. So here is the syntax for the C++ if else condition. So if sensor 0 is greater than 42. Okay, so this is the condition we are checking. This is the question we are asking. Okay, so is the sensor value is greater than 42? Like this. If it is yes, then we have to do something. In our case, we are setting the parking spot. In the sensor, in the case of sensor 0, that we let us name the parking spot SP0. Actually it's a variable where we will store some values. Okay, so representing this parking spot as SP0. Okay, so if sensor value is greater than 42, SP0, I mean the availability of parking spot SP0, I'm setting it to 1. Okay, and you have already seen that at the end of each line you have to put a semicolon, right? Otherwise it will not work. This is actually the syntax, and you need to correct the syntax if it throws an error. Okay, so what we are writing here, if the sensor value is greater than 42, I mean what does here 42 greater than 42 means? It means that if the light is higher, right? The light is higher. The light is higher means there is no car on it, right? If there is no car, we are setting it as 1. Okay. So this we will take some logical decisions. So in the previous class, I have shown you digital logic, right? Where I have shown you to represent something yes or no, we represent this as 1 or 0, right? So here, if there is a parking, I mean, here the sensor value is greater than 42, that means there is light on it. There is light on it means there is no current, so this is available. Okay, so spot 0 is available. So to represent spot 0 is available, I am setting it as SP0 equal to 1. If the parking spot is not available, I will be representing it as 0. Okay, so that's why I am setting SP0 is equal to 1, and it's a variable. Okay, so if you use a variable SP0, I am using a variable SP0. You have to declare it first. This is the rule of this Arduino coding actually. So we have to declare it first. So I am declaring the variable SP0 by which I will be representing the availability of the part. So I am setting SP0 as a first variable, and what if the sensor value is greater than 42? Spot 0 is 1, and if not, then we have to write this like this way. I mean, the decision is like this. Okay, if sensor value is greater than 42, if it is yes, we are setting SP0 to 1. Okay, and if it is not correct, I mean sensor value is not greater than 42. If the sensor value is not greater than 42, what should it be?
0.
0? Yes, 0 is one part of the answer, but if it is not greater than 42, what should be the value of it? It's not greater than 42, so the value is less than what?
1.
Think about it again. The sensor value is greater than is not greater than 42. What does it mean? What is the value of the sensor?
It's less than.
Less than 42, exactly, great. So yeah, so if sensor value is greater than 42, then we will set it as spot 0 is equal to 1. If it is not, then we express it in the coding as else. We write it else. If this is true, then spot 0 is equal to 1. Else, what does else means? If this condition is not true, then we represent it as else. Okay, so if this is the sensor value is less than 42, it means it is dark. I mean there is a car on it, right? It means there is a car on it. So if there is a car on it, the spot is not available. We represent it as 0. Okay, so we will be setting here the value of SP0 to 0. Okay, so this 0 and 1 is nothing but a representation, right? Like 1, we mean that there is an available parking spot. The parking spot is available, and SP0 means the parking spot is not available. So we are writing like this. So if sensor value is greater than 42, SP0 is we are setting SP0 to 1. If not, which is represented by else. If not, then we will set it to what? 0, right? And as you can see that after if condition, you have to start it with a second bracket and end with a second bracket. And in the case of else as well, you have to start with a second bracket and end with a second. Okay, so this is an if else block, simple if else block. This will decide that if there is a car on the parking spot or not. Okay.
All right. We'll take a few minutes and see whether anyone has any questions. Anyone? Because I've been seeing that the room has been really, really silent. You're either getting everything or probably not getting anything. So, I mean, I don't mind the first one, but the second one is definitely worrisome, right? So let us know if you have any questions, and don't be shy. Now, I'm giving you 2 minutes to ask questions from your side. Otherwise, I will go ahead and ask questions to you, and then you'll have to answer. Which one is difficult? Asking or answering? So you have 2 minutes. You can ask anything.
Yeah, ask anything.
Maybe you can ask Uday, what did you have for breakfast? Anyways.
Initialized SP0. I didn't.
Okay.
Exactly.
Could you repeat that question? So, I mean, could you repeat that question so that we?
Yes. So yeah. So here we have to initialize he asked that we have to initialize that the variable because we are using a variable sp0. I'm using this word out of my mind actually. I'm just randomly picking here one variable sp0. We need this sp0 is not recognized by the Arduino coding environment, right? I am naming it sp0. So this is a variable. This is called a variable. To use a variable, we have to declare it first. Okay, so that's why at the first line of your in the first section of the code, you have to declare it. So I am declaring like this int sp0. So what does this mean? This is declaring a variable. It means that I am naming a variable called sp0, and the type of this variable is integer. Okay, because I'm the sp0 or sp. This will be values zeros and ones because I am taking decisions with these variables. I will be setting 0 and 1. So I just need integer type variable, right? So that's why I'm to declare a variable, you have to write this this way. At first, you have to write the data type. I mean, this is I will be using zeros and ones. That's why I am writing integer. The integer will be sufficient enough. And if and let me tell you another thing. What are the other data types? The other common data type is a float. Float means there will be a decimal point. I mean 0.5, 0.6, 0.7. These are called float variables. So you can use float where it is necessary. But why am I using int instead of float? Because the float will actually take more space than integer. That's why I am using integer. Where I am where float numbers, I mean floating numbers, I mean the decimal numbers, I mean 0.5, 0.6, that type of numbers is not necessary. We can use we can just use integer to save memory. Okay. Here in this case, we do not need to save memory, but in real life, the memory is crucial. You have to optimize your project or code so that it can consume less memory. So this is a good practice. So
why we also add on to that point. Udoy really explained it really nicely, and he gave you the real reason. But I don't know whether you caught the seriousness of this. Okay. For example, the reason why he has to keep mentioning this is an integer, this is a float, is because depending on that, it allocates a specific number of memory, like memory bits. Is it 8? Is it 16? Is it 10? Is it 12? Right? Maybe you are saving 2 bits per variable by mentioning that this is. We don't need float. We need integer. Okay, but what's the big deal? Who cares about 2 bits? We have megabits, gigabits, and whatnot, right? Did I tell you? In the grand scheme of things, when you go for a large-scale processor, 2 bits, 3 bits will add up and end up being millions of bits and billions of bits. Okay, if you save 1 bit per instruction, you might end up saving thousands to millions to even billions of bits. So then billions of bits mean 1 gigabit. Now, do you care? Right? So apparently this is a very good practice and we have to do it. That's why it has been mandated that you have to definitely mention the type of the variable that you're using. And by the way, let me ask questions now to you and see whether you can answer. And you can be wrong. No penalty for being wrong. First question, Udoy showed you, Udoy, can you go to that if-else condition? He showed you if something happens, then do this. If not, do something else. No, the actual code. Right. When I expected a question from you, hey, okay, so now we are dealing with 2 things only. It could either be less than threshold or above threshold. What if I'm trying to sense 3 different situations? Is it less than 20? Or is it between 20 and 60? Or is it above 60? So there are 3 conditions. Is it less than 20? Is it between 20 and 60? Or is it above 60? What do you do to this one, to this line? How can you accommodate that?
You would add 2 more else.
Yeah, that's you are right. But there is one small factual mistake, that is we don't keep using else, because otherwise how would it know whether this else means between 20 and 60 or above 60? We have to specify another condition. So we use if, else if, and then else. Right?
Yeah, that in that case, if you have multiple conditions, you have to write like this. You have to, because there are 3 conditions. If the variable, the sensor value, sensor is greater than suppose 80. then do something. Okay, and we use LC to represent the middle conditions. I mean,
You can use as many LCs as you want.
yeah. So suppose the value we are searching that. We are asking the question that if the sensor value is in between 40 and 80, then do something. And the last condition will always be else. Okay. You can use else if again one other else if maybe. If the sensor value is between 20 and 40, then do something. And the last condition will always be an else. Okay, that's how you actually else. So suppose let me draw a table to represent this actually. So if the sensor value is greater than 80, okay, and the sensor value is between 40 and 80, and the sensor value is between 20 and 40. Okay, so we have represent this the first line using this if condition, and the second line using this else if, and the third line using else if, and there is an else. For else, I do not need to specify these kind of ranges. Okay, why? Because if the value does not fall in any of this, it will go to else. Okay, so what could be the value of else? I mean, suppose these all the sensor value is not inside this table. So what could be the sensor value? I mean, the sensor value those are less than 20. Will it fall in any condition here? If the sensor value is less than 20, it will not fall in any category. Then it will fall to else. So all the else's are all the other conditions will go to the else block. Okay, that's how if and else block.
There is an advantage of using else as the last argument. Can anybody guess what that is? Have anybody ever seen a computer system freeze? Like, oh, it's not responding, and then you have to forcefully restart it and do something like that. Might be. Have you seen in a movie that a robot might freeze if you give it a problem that it cannot solve? Like, should I do this or that? And then it freezes, right? I don't know.
Or it gives you like a way out if you like pause.
Exactly. So the thing is, what if you miss a condition? Like you forget. This is an easy enough problem, right? But when you actually write codes, there are maybe hundreds of possible combinations, even more, with different variables. If A equals 1, B equals 2, C equals 3, do this. If A equals 5, blah, 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 right? There could be hundreds to thousands of possible combinations. You only care about a few. You use them in terms of if this happens, do that. Else if that happens, do that. And then you don't care about everything else, just write else. Whatever happens, do something else, right? So you cover everything and you avoid the chance of missing out a combination that might accidentally occur and freeze the system, okay? So that's why these simple things have meaning. Obviously, I totally understand that you're not getting a full-fledged training on C++, but this, tiny little things have a lot of insights in it. So by the way, my intention is not to teach you LC for reason, because there are so many other things to teach. My only intention is to show you that if you don't ask questions, you'll miss out. Okay, so don't let us get away so easily. Please ask questions.
Yeah, go ahead.
So can you go back to the circuit real quick?
Circuit.
Thanks, Adam.
I mean, in this. Yeah.
So here, I don't know. So right here, you see how this one's going right here, this one's going here. Does it matter if you put on E or D or C or B? Like, do you know what I'm trying to say? Like how this one's on E and this one's on D. Does that matter which one you're putting it on? You know what I'm trying to say?
What
like you see how these two are on the same? They're both on C and this one's on E and D. Does it matter which one you put it?
So you see, you're saying like these two are on C and D. So this has to match up with this, right? This has to match up here. This needs to match up here. This needs to match up here. But if you take this and move the entire thing, say right here, your wires will need to go there and there. So it's dependent upon where you put these.
Okay.
Does that make sense?
Yeah.
Okay.
Yep, so I think yeah, for this you have to know that how the pins are connected in the inside the breadboard. Okay, so the first two lines in the previous classes I mentioned that the first two lines here it's a good learning tool actually. So you can hover the mouse on the pins and it will show you which pins are connected. Okay, so these pins are connected, these pins are connected, and in these two these two rows. These are connected vertically, as you can see. If I hover the mouse on any pin of the line, it will show which are connected. Okay, so if I hover the mouse here, it will show that these all pins are connected. Okay, so this is a photodiode, and this is the negative terminal of the photodiode. So the negative terminal should be connected to ground. This is my ground. Okay, this line is my ground. So I need to connect this negative terminal to the ground, and the whole the negative terminal here, as you can see, let me zoom in. So as you can see, the negative terminal is connected to this line, and this line is fully connected. Okay, so if you take any pin from this line and connect it to ground, this will actually connect this to the negative terminal of the photodiode. Okay, so if I connect this photodiode, the negative terminal of the photodiode to this line, the whole line will be the negative terminal of the photodiode. You can think it this way. This whole line is the negative terminal of the photodiode, and this whole line is the positive terminal of the photodiode. You can take any pin and just connect it anywhere else, and you will have to assume that this is the positive terminal of the photodiode, this line. So that's how actually the breadboards are connected. So yeah, and let's move to the if-else condition again.
Can I ask a question? I just wanted to ask, you said the semicolon after each comment. So do we do also for if else or just
yeah, this is a syntax actually. So that's how you have to write. The programmer, develop this language. There are several languages, by programming languages. So there are some rules of writing some this kind of if else conditions. So this is the rule. After it, you do not have to write any semicolon, but for other lines you have to put semicolons.
Yes. It's my first time doing coding, so that one quick question. So first you said the integer SP not. So I understand the sensor one is connected to printing sensor. This command connection. Are you going to do for where are you connecting SP1, SP0 to sensor value 0?
Yeah. Okay. So here actually I'm not directly connecting SP0 to sensor 0. I am actually using an if-else condition to set the value of SP0.
But we don't know which one is SP0 yet.
No. Yeah. We have just based on sensor value here in the if-else condition, we are actually setting the value of SP0.
Okay.
Okay. We will set SP0 to 0 or 1. Yeah.
What does the syntax mean?
Oh, well, syntax means the rule of writing. I mean, you have to put semicolon after the statement, and to write the if condition, you have to put a bracket. So these rules are called syntax of programming languages. So you there are many programming languages, like Python is the most popular one. Python, the C, C++, etc. So let me ask you a question. Have you gone through any programming languages in your school or anything? So this is your first time. So this is a good one, because if you first learn programming language, then you will feel it boring because you do not know the application. Here you are observing the application first, then you are learning. Then you will be motivated to learn programming languages. Okay, so this is good for you actually. You have started with the application of programming language. That's good for you. Okay.
May I add a point with that? Thanks for that. And Muhyiddin, that's a great question. That gives me the chance to add a story here. Do you think the machines understand, or that simple microcontroller understands what you mean by serial, print, sensor? Can it read and write? No. Your processors, your computers, all will only understand two things: zeros and ones, binary. And that's what I talked about in the very first lecture. Remember, we just deal with binaries, ones and zeros. And depending on that, something will turn on, something will turn off. That's all, because these are all switches. So how are we even managing to feed this text to the machine? Because there are other additional layers. If you choose a path of computer science or something that involves coding, then you'll learn ins and outs of that. But it starts with machine language, and that's always binary. And then there will be a layer of languages that are more difficult to write. So over the years, engineers abstracted out those levels and made it easy for us, as if we are just teaching someone what to do. Like at some point now, almost now, you can just ask ChatGPT to write a code that will do this, and ChatGPT will write a code. So you're basically making it so easy for the next generation that nowadays there are situations where you can just drag and drop stuff. You can drag a for loop and it will do a for loop. You can visibly see that this is going to be a loop, right? So engineers, every generation, started making things easier for us. They decided on that syntax. Here is how you should write if condition. Here is how you should write print. So different programming languages have different syntax, as Udoy mentioned, right? But everything will feed down to what? The machine language, binary. Doesn't matter whether you're using this particular syntax or Python syntax or C syntax or Java. They will all have different styles. And no need to freak out. If you learn one language, it will be super easy for you to learn the others. And syntax is the least thing to worry about, because there are compiler that will help you correct mistakes if there are any mistakes. So you don't have to memorize that. Oh, I missed a semicolon there. It will show you you missed a semicolon.
Thank you.
Sure.
It's kind of like grammar.
Yep, exactly.
Yeah, so let's do the mistake and check. Maybe. So let me just do a syntax error. Okay, let me show you that. So I am missing, so I am removing a semicolon here. Let's see what it throws. Okay, so as you can see, there are errors here. So this is some syntax errors. So there are several errors here. So I have intentionally just removed the semicolon and it throws errors. So before running this, you have to correct these syntaxes and then move on. So I'm putting a semicolon here, and this is. Yeah. So here, as you can see, I have forgotten to put a semicolon here as well. It will throw you actually. So you have to abide by the syntaxes, otherwise it will not compile. What does it mean compile? Dr. just told you that compiling means I have written code and it will feed the machine, right? So this is this kind of compiling. I mean, so before running the code, we have to check the mistakes. So let's go back to the if-else condition. Okay. So I have taken the decision for the parking spot 0. Okay. Let's in the same fashion, in the same similar way, we have to do this for all other sensors as well. So I will be just copying and pasting the code. So I have taken decision for sensor 0, and I will be taking decision for the other sensor as well. In the next if-else block, I have just copied and pasted this block, and I will be taking the same decision for the sensor 1 value, and for the sensor 1 value, I am naming the parking spot as SP1. Okay. Exactly in the same way, I am actually creating another variable which is SP1, which will show me the availability of SP1. So in this block, I am setting the value of SP1, which represents the availability of the parking spot. If the sensor value is greater than 42, I mean there is light on the parking spot, that means there is no car on it. I am setting the SP1, I mean the availability of the parking spot 1. I am setting this to 1, and if in other condition, I mean if there is no light on the parking spot or on the photodiode, there is no car and there is car, so I am setting this as SP1 equal to 0. So SP1 equal to 1 means there is no car and the parking spot is available. SP1 equal to 0 means the parking spot 1 is not available. Okay, so let me do this for all other sensors as well. I have 2 more sensors. So in the third block, I'm naming this as sensor 2. So if the sensor 2 value is greater than I'm setting another variable which is SP2. SP2 will SP2 will represent the parking spot availability of the third parking spot actually. So I have started with number 0. That's why this is sensor 2, but this is the third parking spot. So let me do this for the last sensor as well. So I have done same thing for the for all the sensors actually. So I'm taking decisions. So I have declared SP0 variable, but I have not yet declared the other variables SP1, SP2, SP3. SP1, SP2, SP3 is my variable, so that's why I need to declare it. So SP0, and I have to declare SP0, SP1, SP2, SP3. So this is actually one syntax that you have to declare the variable names before you use it. Okay, so I'm using the variable SP0, SP1, SP2, SP3 here. Before using this, I am actually declaring them here, right here. You have to declare it, otherwise it will show you error. Okay, so I have done this for all the sensors, and let's check if you can check if there is any error by clicking on start simulation. If it is not red, then the simulation is running fine. So here, this will not show something valuable. I mean something fruitful to me, because this is taking decision internally. We are not seeing the output of the decision. Okay, so what will be the output of the decision of this kind of decision? So we will add. We have added the inputs in the microcontroller, and now to see the output, we will add an LCD LCD display where we will be showing there is some available parking spot is 4, available parking spot 3, etc. And there is no parking. If there is no parking spot available, it will show do not enter. This kind of thing we will show this on a LCD display. If practically we will have an LCD display. I have mentioned in the previous in the earlier part of the class that we will be using an LCD display, which is a 16:2 LCD display. So let me bring that. So before bringing any circuit element or editing any circuit element, you have to stop the simulation, and then if you need to go back to the component list. Currently it is showing me the code. So to go back to the component list, you have to just click again on the code. This but you have to click on the code. Yep, sure.
Sorry, you just went off of it. I was wondering if you could go to the very top part of the code again.
Yep.
So it's very specific where you put the variables in at the top, but there's no space in between, just dividing them by a comma and no space.
You can put space, no problem, yeah. But yeah, I'm not putting any space.
Okay.
You can put a space. Yeah, there is some syntaxes. Yeah, you can put some spaces, but you cannot do this like this. You cannot go to new line like this.
Right.
You cannot do that. Okay, so they have to be in the same line, and after that, put a semicolon and at the end of the line. So yeah, so you can. Let me just put some spaces between them and check if it throws any error. It doesn't throw any error, so you're fine. You have to put spaces. Okay, so yeah, so let's go back to the component list. So if you press on the code, it will take you back to the component list. So here you have to search by LCD. In the search box, you have to type LCD, and there are several LCD options. We will take the last one, LCD 16:2 I2C. Okay. So yeah, from this list you have to select. You have to select this. So note this. Actually, we have to select this number, this LCD where I2C is written. Okay. So I'm selecting this and putting this on the in design environment. Now you may ask a question that there are two available LCDs. The first one is LCD 16x2 and the second one is LCD 16x2, and there is a I2C after this name of this LCD. So what is the difference between these two? Let me take these two and keep them side by side to compare. As you can see, in the left LCD, there are many number of pins, like 16 or 17 pins. But in the case of I2C, there are only 4 pins. So using this LCD is very convenient because this one is a older one and this is the modern one. In the modern LCD, you will have 4 pins, and that's why we are using the modern one, and we are not going to use this 16 or 17 pin version. We will be using this 4 pin version, and you will find this 4 pin version here. LCD 16x2 I2C version. Okay. So we will be using this LCD panel, and as I have mentioned that there are 2 lines here. It is not showing right now, but yeah, when we actually connect this to the microcontroller, then it will on the display, and we will actually set what should we display, display on this. So this is, as I have said, told you that this is 16x2 LCD. 16x2, the 2 means the 2 here means there are 2 lines, and in each line you will have 16 characters. You can print 16 characters in first line and 16 characters in the second line of this LCD. So before talking much about this, let's just connect it to the Arduino and see what happens. So there is a convention to connect this to Arduino. As I have previously mentioned that I have not used the analog pin A4 and A5. Okay, why? I have to connect this A4 and A5 pin to the LCD display. So the convention is that you have to connect the A4 pin to this SDA pin. This is serial data line actually. Serial data means I mean the Arduino will send data via this line actually. And there is another serial clock line where the convention is that the A5 pin of the Arduino should be connected to the serial clock line. Via this serial clock line, it will send the clock pulse. I mean, to run this display, there we require a clock pulse. So that will be transferred through this STL line. And keep in mind that STL line should be connected to A5 and SDL line should be connected to A4. This is the convention of this LCD actually. So they made it this way. Okay. So we have to connect like this. And there are 2 pins left, which is the ground. You know that ground should be connected to the GND line. So I'm taking a line from GND and connecting it so that I have already created a ground node, right? Do you remember I have created a ground? The topmost line here is the ground line. I created it before. So I'm connecting this the ground line to the LCD display, and to power up this LCD, we need to connect this VCC pin. So via this VCC pin, the LCD will get power. From where will it get power? From the Arduino. The Arduino can provide power to the LCD. So I have to connect this VCC. So the LCD takes 5 volt to run. So we have to connect 5 volt to VCC, and there is a 5 volt pin inside the Arduino. So here, as you can see in the bottom side of the Arduino, there is a pin. There is a pin which is 5 volt. So I have to connect this 5 volt to the VCC of this. So that is how you will connect the VCC. I mean the LCD display, 16x2 LCD display to the Arduino boards. So there are 4 pins. It's easy to connect, but in the older version, there are 16 or 17 pins. So we have to connect each and every pin. That was actually that was actually messy, that they came up with a new LCD panel where we have to connect only 4 pins. So it makes our work easier actually. So the LCD is connected, but we have not coded it yet. We have not written any code for this LCD to run. Okay, so let me write code for this LCD. So let me go to the code section. I'm in the coding section. Okay, before going into the LCD section, let me tell you another thing. What was our project goal? Let me show you that. Okay. So in the display, we will be showing how many parking spots available. Okay, there will be a central screen. I mean, this display can be inserted in the entrance of the parking lot, and there we will be showing how many parking spots are available. Okay, so here we have to show how many parking spots are available. Okay, so to do that, how can we get the available parking spots number? Let me go back to the code. So here, if the parking spot is available, we have set it as 1, right? Let me draw something. So at this point, do you have any question? Okay, after this, maybe you will have some question. Should we take a break or something? Everyone looks exhausted.
Okay. Maybe in 15 minutes, if that's because the pizza is on its way.
I think we can cover it. Yeah, already 70% is covered.
Take a break now or okay, let's take a break because everybody looks exhausted. It's better take a break, freshen up, and pizza is on its way.
Okay, so what is the display? I mean, the structure of the LCD display is like this. Let me draw this. Okay, so I have told you that this is a 60 cross 2 LCD. Okay, so we have 2 lines. There are 16 places here. Yeah, you can print characters inside each box, and there are 16 boxes, and you have 2 lines of. Okay. So and what have I write in what I so here I have written that LCD.set cursor 00. So it is setting a cursor. Okay, I have done case mistake here. So the cursor is the C of the cursor should be uppercase. Okay, okay. So here what this line will do, it you have to tell the LCD that from where should it start printing. Okay, so at it this is the this box is called this is 00 box. Okay, the you can think this of as a coordinate. Okay, what will be the coordinate of this box? We are assuming this is 0, 0. So we will start printing from here. So that's what I have written in this line. LCD.set cursor. I am setting the cursor to position 00. So it will start printing right from here. Okay, from the 00 position. Okay, we have to we have to tell it to the LCD display from where it should start printing, and in the next line I will write what should we print. Okay, so we can print. Let me write it. LCD to print something. The command is LCD.print. Okay. So we want to print something. Okay, so to test the LCD, we'll just let's just print something. Let's write. Let's see it. whether it can print something or on the LCD display or not, to test whether the LCD display is working or not. So yeah, I think right now it should print something. I mean, you can write anything inside this double inverted comma, it will print. And let me check that if the LCD panel is working or not. So it should, okay, there is a error. Okay, I got it. So here what you should write, I have named the I have named the LCD display as LCD1. Okay, and you have to write the same thing here. Okay, I have declared this LCD as LCD1, but I am writing here LCD. It will not work. Okay, so we have to correct it. So here we have to write the same thing that we have named it in the beginning of this code. So LCD1. Okay, because I have said the name of this LCD as LCD1 here. So I have to put LCD1 here. Then I have to put this command dot set cursor or dot print, whatever. So let's start a simulation again. Okay, so throwing another error. The set cursor is for some reason. Okay. It's again the syntax error. Okay, so the syntax is actually the S should be the lowercase and the C should be uppercase. So you can just, you do not need to memorize this thing because you will use different devices. You cannot remember every command of every devices. You can just search on the Adafruit library commands. You will get. So the set cursor, if you face this kind of error, just check it. The command is correct or not. So as I have mentioned you that this is sensitive, so you have to be careful about the lowercase or uppercase letters. Let's run it again. Okay, now it's correct. So this is called debugging. When you write codes or programming languages, surely at the first run or second run you will face some kind of syntax errors, and then you have to debug the code. Okay, so let's go back to the circuit and let's see if it is printing something correctly or not. Prints this. Okay.
Check the LCD. Check LCD1 to LCD_1.
Yeah, I'm just checking because there is nothing on the LCD screen actually. That's why I'm just checking the value. Is yes. Yeah, correct. Okay. Oh, I need to do another thing actually. This is all about syntax. there is another initialization line. We have to also set something in the setup, because we to initialize the LCD display, we need to write one thing again. We need to begin. There is another command to begin the LCD, so we have to put it in the setup section. That's what I was missing. That's why nothing was showing in the LCD screen. So let me write that. So the command is, okay, I think this is fine to put LCD_1 or LCD1. LCD1 dot begin. So we have to insert this command as well in the setup section. Keep in mind that this should be done in the setup section. This begin command to be. So, and you have to tell it that this is a 16 cross 2 LCD. Okay, so you have to put this line. So to use the LCD, so you have to include these 3 lines. The first 2 lines will be above the setup, and this LCD begin line should be in the setup module. I mean setup function. Now let's try this. So now,
Something.
it's printing something. So this is how the LCD screen looks like. As you can see, this is something, and if you count these boxes, you can see some boxes, right? Inside there are 2 lines, and there's you can print 16 characters, and there are 16 boxes. Okay, let's do the main thing of the project maybe. So we do not want to print something. we want to print something helpful. Okay, so let's do like this. In the first line, we will be stating that available parking spots, and in the second line, the number of parking spots, like this. Let's do that. And there will be some issues. Let me show you that. Available parking spots. So in the first line, it will print available parking spots. But keep in mind that the first line only contains 16 characters. So let's see what happens. So I have written available parking spots, but it is only showing available parking. Do you know? Can you guess why?
Because it can only show 16 characters.
Yeah, it has only the first line has only 16 characters. They can only print 16 characters. Okay, so the rest of the characters is truncated here. Okay, so what can we do? So we have to keep in mind that we can print only 16 characters. So we can write like this. So available parking and the spots in the next line. So let me, and to print in the next line, you have to set the cursor for the next line, and the next line. Let me just copy and paste this. So currently we are in the first line. Okay, so we need to move to the second line. To move to the second line, we have to insert this command again, and we have to put the position 0. For the second line, we have to put 0, 1 here. So for the first line, we have to put 0, 0 here. In the set cursor value should be 0, 0 for the first line, and to print something in the second line, we have to set 0, 1. Okay, in the set cursor value, and then we should insert again a print line here. So in the first line, we will write available parking, and maybe in the second line, okay. We are just testing the texts. We have not printed any value yet. Available parking spots. Okay, so currently we are fine, right? Now, what should we print here? So I have actually, sorry.
The sum.
Exactly, yeah. So because I have stored the value of available parking spots inside the variable sum, right? So we have to print the value of sum after this available parking spots, then the value of sum. Okay, so I cannot write, so let's write it. So we have to write another line of LCD dot print. So here, so when you write a variable value, when you need to print a variable value, then you do not need to insert the double inverted. Okay, here is the syntax. Let me write it. So I want to print the value of sum. So when we want to print some variable value, you do not need to insert the double inverted comma. Okay. So for this, I want to write this available parking on the screen. So that's why I am putting double inverted comma and this force double inverted comma. Now these are not variables, right? These are some text, nothing else. So to print variable, you do not need to just double inverted comma. Then in this case, it will print the value of sum. Let's run this. I think, yeah, so right now, as you can see, all the sensors are in dark mode, right? Dark mode means there is already car on that. So available parking spot should be 0. What is this is what showing here. So let's suppose the second parking lot, the car of the second parking lot goes away. So let me put it like this. Then it's updated to available parking spot 1. Can you see that? And then let's assume that the last parking spot is also available right now. The last the car of the last parking spot goes away. So I'm representing it at this, and this will update. This will be updated to 2. Okay. And in a similar way, if all the parking spots, yeah. So I have actually set all the parking spots to available. So this is showing available parking spot 4. Yeah, this is pretty much it. Okay. So this can do the thing. Okay. So up to this point, do you have any questions regarding the printing? I mean, regarding anything, specifically regarding the printing section or anything else. Do you have any question? So yeah, if you get this Arduino and this LCD panel, this sensor, can you do the project? You have to just connect it and upload the same code to Arduino. I need to show you another thing that after you get the Arduino, I will show you how to burn this Arduino. Burning, it doesn't mean I will fry this. Burning means uploading the code. Okay, so this code can be uploaded to the Arduino. When we upload something on the Arduino, we call it burning the Arduino. Okay, so we will upload this, burn the same code in the physical Arduino, and we'll do it via a USB cable using our laptops or computers. Okay, so this Arduino can be connected to the laptops, computers, and etc. Wherever available. So yeah, so I think this is pretty much it. So if you yeah.
Right, so basically, one of the little photo things, they're available when they're exposed to sunlight or light.
Yeah.
So would you just cover it up to make it unavailable?
Sorry. Yeah.
So basically, the what do they call it?
Photo.
So when they're exposed to light, they're basically available and they can use. If you cover them up, could they be like?
Exactly. Yeah. So the light hits on the photodiode. When the light, the amount of light is greater than or higher, then actually the photodiode generates higher output. And if there is a car on it, the light on the photodiode will be very much low, right? Because it will be under the car. So car will cover up the photodiode, and light cannot hit on the photodiode, and it will generate lower values. And that's how we are actually determining if there is a car there or not. Yeah, that's how. So, do you have any other question?
So for next class, we're doing this and
yeah, we will do hands-on.
So it's using the same code.
Yeah, using the same code. Yeah, we have, as I have told you, that we have done already 70% of the project. The code is the main thing. You just have to connect and just upload this code and check if it is working or not. That's it actually.
So and in the Tinkercad?
Yeah, it's all, it will be automatically saved in the Tinkercad. It should be available on your profile, I think. And I will upload the code, and I think that the code is already uploaded in the slide. The code is already copy and pasted in the slide of today's slide actually. You can go there and just grab the code. And yeah, I think you understand every part of the code right now, right?
So everyone needs to bring their, sorry, last question. Bring their breadboards and
Yeah,
and their laptops.
Yeah, exactly. Yes, yeah. In the first part, we actually distributed the first set of hardware to you, and those who were absent in that class, you can just your your equipments. This is the first set of equipment. You will get the second set of equipments in the next class maybe. Yeah, those who have missed, you can just take it. It's here. So yeah, go ahead.
You said we'd be using like an Arduino Mega.
Oh yeah, that's what actually there are as I have mentioned that there are three Arduinos, right? Three versions of Arduino. The big one is the Arduino Mega, and the second one is Arduino Uno, and the smallest one is the Arduino Micro. Because we have 4 parking spots here. In this project, we can use 4 parking spots. Okay, but to increase, because as you can see, there are limited number of analog pins, like from A0 to A5. Okay, these are the input pins. The other pins you can see, these are digital pins. We cannot use that to read the sensor data. Okay, so to read the sensor data, we have only 6 pins, and among the 6 pins, we are using 2 pins for the LCD. So we have only 4 pins remaining. So we can use 4 parking spots. But if we think that this is enough to understand the project. But if you want a bigger parking lot, suppose there are 16 cars. Well, I mean there are 16 spots to park. Then you will need Arduino Mega, because that will that Arduino Mega has 16 input to it. But we thought that 4 and 16 is the same thing. If you can do it for 4 parking lots, you can do it for 16 parking lots as well. As you can see that the code are just be copy pasted. You can code for one, and you will just copy paste for other sensor, other parking spots. So if you can do that for 4 parking spots, you can do that for 16, 50, 60, 100, whatever, right? You have to just copy and paste the blocks. Okay.
So in the slides on the project code, hence are all the variables there that we will need. You just change the values or add to them, or
I think you can use the code of the slide, but maybe I have done that from scratch here. Maybe the variable names are different from the slide code actually. So that doesn't matter, because you can name anything in the variables. Okay. So the variables name from this class and the slide could be different, but that doesn't matter actually.
So how do you connect 16 to another 60, another?
I mean, multiple Arduinos.
Like if I want to apply for the whole parking lot.
Yeah.
You're
So
telling me only 64.
So for 64, we will there is another bigger Arduino, which is Arduino Mega, which will have 16 input pins, and from this Arduino Mega we can cover 16 parking spots. For 64 you will need 4 of them, and yeah, the Arduinos can be connected. There is a transmission.
Can I have like tell them to talk to each other?
Yeah, it's possible, because there is a communication line, there is a communication pin there by which we communicate between the Arduinos, among the Arduinos. So, is there any other question?
Will we have to solder anything?
Solder, no. Yeah, we'll do that on the breadboard. So we don't need to solder, but the previous version of the LCD needed to be soldered. That's why I actually moved to the modern one. You do not need to solder anything. You will have male to female jumper. We will show you that. the jumper, and you can use the jumpers. You don't need to solder anything in this.
In another experiment, that's for sure, don't worry. But we have to make sure that you don't burn yourself. Safety first.
Individual, right? Everyone doing their own.
Yeah, we have to plan that.
Final question. I think A4 and A5, you can't displace it. Always have to be A4 and A5.
Exactly. Yeah, it should be always A4 A5 because the manufacturer said it that way.
Mega, Arduino Mega is
No, not for Arduino Mega. That should be something different, but I currently do not call that. Yeah, if we search in the internet, you can whole library. Yeah, that's that. That was it. Because
okay. So you can only access that. Thank you.
Yeah, they are all semiconductors.
We're gonna be doing.
Yeah.